Hi, everyone. Welcome, welcome. Thank you for coming. My name is Mark Milner. I'm a staff software engineer at Ava Labs, and I'm also a technical lead for the data platform team. And the data platform team, we run a variety of data ingestion pipelines and also build a few APIs and backend services, one of which is the Glacier API, which I'll be talking about today. So before I get started, just a quick show of hands. How many of you have heard of or used Glacier API? I should see a few hands because there's a few Ava Labs in place. Okay, a few of you. For those who haven't, how many of you have used the Core app or Core extension, Core mobile, or the Avalanche Blockchain Explorer? Okay, cool, awesome. Good to see that. So without knowing it, all of you have used Glacier already. Glacier powers all of Ava Labs' front-end applications today. So just a quick overview of what I'll be talking about today. I'll give a high-level overview of what Glacier is, and also I want to talk about why Ava Labs decided to build this API in-house as opposed to using existing services that exist on the market today. Then I'll give an overview of some of the features and dive a little bit deeper into some of the interesting features that Glacier supports. And at the end, I want to kind of show you where we're looking to take Glacier in the future. And I want to leave some time for questions and answers at the end that you might have. So to start, what is Glacier? So it's an API that serves blockchain data, but specifically it's serving blockchain data that isn't easily accessible from blockchain nodes like Avalanche Go or Go Ethereum. And so it serves a variety of use cases that aren't easily done using those blockchain nodes. So the typical example I like to use here is getting all of your ERC20 balances for your wallet. So using the blockchain nodes, you might be able to look up the balance of a specific contract address, but you have to already know what that contract address is for the ERC20 token. So Glacier indexes things like that and is able to give you a complete list of all of your ERC20 balances that you can use in your applications like wallets or portfolio viewers. So what chains do we index? We index all of the Avalanche primary network chains, so the P chain, the C chain, and the X chain. And we also index a variety of EVM compatible blockchains and subnets. So if you've built your subnet with Subnet EVM, we can index that for you and serve it with Glacier. And we also are EVM compatible, so we can index other chains like Ethereum, which we also serve today. And like I mentioned, this powers all of our front ends, so our Core web app, Core mobile, and Core extension wallet. It powers our Avalanche Blockchain Explorer, and it also powers a variety of internal use cases at Ava Labs. And I'm happy to announce it's in beta today, so you can use it today for free. So why did we decide to build Glacier? Why didn't we just use an existing indexing provider? ETH has been around for a while. There's a variety of EVM indexers that are out there on the market, both hosted and self-hosting solutions for that. So why did we build this ourselves? Well, there were a few reasons. One, when looking around at the market, a lot of these were slow to adopt new chains, and I'm talking about the hosted solutions. And we wanted to be able to provide support for all of our subnets as soon as they come online. We don't want to have them wait until a partner that we were working with adds their chain. And our primary network chains have a variety of non-EVM features, and we, as the developers of those chains, are best equipped to index those as new features come along and changes evolve. So we also wanted to build an API that can serve our front ends in a way that was both reliable and efficient so that we could provide them with the performance we want from our applications for our users. But while we built this for our front ends, one of our original goals was to build the API in a way that was agnostic to front ends. So we don't want to leak implementation details of what we're doing with our front ends in the API because we want others to be able to use it and build their own interesting applications on top of that. And that brings us to my last point, which is we wanted to reduce the time to market for our customers. We don't want customers and subnet operators to have to focus on building indexing solutions for their blockchains. They should be able to get that kind of tooling out of the box with something that Ava Labs provides them. And that way they can focus on building their applications. So now I just want to dive into a few of the existing features that are on Glacier API today. And these are using screenshots from our own front ends that I've mentioned. So first, let's look a little bit at the different features we have for our EVM chains. So 2 foundational data structures that you'll see in any EVM blockchain, as the name suggests, are blocks and chains. And so we provide both chain data and block data, so you can get a detailed view of both of these. On the chain side, with our chains endpoints, you can see information such as what VM is running, and you can also look up things like what the public RPC URL is, so you can look up data from the chain itself. On the block side, we give you a detailed view of blocks, including the transactions in those blocks. Now, a lot of this data is already available on chain, but we provide this data in Glacier as well to provide a complete API. Going a level lower, within each block, there are a number of transactions, and Glacier provides a detailed view of all of these. And a lot of this data is on-chain too, but Glacier provides an enhanced view and pulls in some additional data that's not easily accessible. One example are method names when a transaction is interacting with a smart contract. On-chain, what is stored is a method hash, but that method hash isn't very useful for a user. They don't know what's going on. So Glacier maintains a mapping from method hashes to method names so that we can return you the method name that was actually called. So you get a clearer picture of what actually happened in that transaction. Another piece of information is the price details of how much that transaction cost at the time of the transaction. This isn't data that's easily found on-chain, but we pull that in using a variety of pricing providers. In addition to the high-level details of a transaction, we also tell you what happened as part of that transaction. So we return information about internal transactions, which are basically subcalls that happen as part of smart contract interaction. Additionally, we provide information about ERC20, ERC721, and ERC1155 transfers that happened as part of that transaction. So because we index all of this data, we're also able to index it in different ways to provide different views for users. And one of this is address activity. So giving a user a complete picture of what transactions occurred that affected tokens for that address. And so we provide a holistic view that lets you see all the transactions that happen for an address, but we also provide some sub-views like what are just the ERC20 transfers that move tokens into or out of a wallet address. 2 additional features Glacier provides are balances and NFTs. So Glacier indexes interactions as soon as the first swap happens. So you'll be able to see balances as soon as you've interacted with an ERC20 token for the first time. In a lot of other wallets, you have to actually manually add tokens, but with Glacier, you can get a complete picture of what the balances are for an address. With NFTs, we also index NFT metadata as soon as an NFT is first minted. And this includes NFTs that are both following the ERC720 spec as well as the ERC1155 spec. And a lot of this metadata is stored off-chain, either in providers such as S3 or decentralized solutions like IPFS. And so we pull this data in from those storage solutions and are able to serve it to you in Glacier fast as soon as the NFT is minted. So those are some of the EVM features. I want to talk a little bit about the features we provide for the primary network chains as well. So the X chain, the P chain, and the C chain. Similar to EVM, we also provide the high-level information about transactions and blocks. Because the VMs on these chains is a little bit different than the EVM, the transaction details are also a little bit different. There's a variety of different transaction types, and Glacier provides this way provides this data in a way that's easily digestible. Additionally, for the primary network chains, we also serve information about balances and UTXOs on these chains. For UTXOs, we provide details such as whether the UTXO is locked or staked or spent. And so P-chain and X-chain support is available today, and soon after Summit, C-chain atomic transaction support will be available as well. So I'm going to show off a few feature demos of some of the things I find most interesting about Glacier. I'm going to play a few videos that show some of these features off. Okay, video's playing, cool. So in this first demo, as I mentioned, Glacier indexes ERC20 tokens for an address as soon as the first interaction happens. So in this demo, I'm doing a swap on a wallet that hasn't interacted with USDC before. And the wallet didn't show USDC as a balance, and neither did the core extension. But as soon as the swap happens, the USDC shows up in both core web and the core extension. So I'll play that video one more time just because it goes a little quickly. And full screen it. Well, full screen did not work, but you can see that USDC is not in the wallet. I'm performing the swap here. And immediately, the USDC shows up in the extension as well as core app. So the next feature that I mentioned earlier was minting the NFT metadata as soon as the NFT is minted. So I already have an NFT with some metadata in this wallet here, and I'm using JPEGs to mint a new NFT collection with some additional NFTs and some metadata of their own. And so I'm creating the collection here, and you'll see as soon as the collection is minted and the NFT shows up in the core extension, the metadata shows up there as well. And JPEGs under the hood is using IPFS to store the metadata. So the NFTs show up, and if I scroll down here a bit, you can see the metadata description shows up there, and that's coming from IPFS. So the last feature I want to show is what I find one of the most interesting features of Glacier, and this is a complete transaction history. Now, most explorers, you can get a transaction history already, but they miss some complex transactions where there's smart contract interaction that moves tokens into and out of funds, or moves tokens into and out of a wallet where the wallet didn't initiate the transaction. So a good example of this kind of contract interaction is buying an NFT on a marketplace like JPEGs. So when you buy an NFT on a marketplace like this, or when you list an NFT on a marketplace like this, you sign a transaction that gives the marketplace the ability to sell that NFT on your behalf, but the transaction that actually moves the token out of your wallet is initiated by another wallet address, namely the buying address. And so in this example, I have two demo wallets. The first one is listing an NFT. The next one is buying the NFT. And at the end, you can see that the history for the first wallet, the selling wallet, shows the transaction history, shows in the transaction history the transaction where the sale happened. And it goes by a little fast, so I'm going to play it one more time. Full screen doesn't seem to work, but I hope that's big enough for you to see. So I'm listing the NFT here from the first wallet. And you see that rather than approving a transaction, what it's actually doing is just signing something that gives the marketplace the ability to sell on its behalf. And that was just the approval to give the marketplace the approval to do that. And so I'm switching to the second wallet here. Connecting the wallet to JPEGs. And buying that same NFT. So the buying wallet initiated the transaction, but the transaction history still shows up for the selling wallet, which you'll see here. So it's a little small, but you can see how the NFT moved out of the selling wallet. And that's one of my favorite features because users really care about any time tokens move into and out of their wallet. It shouldn't matter if they were the ones that initiated the transaction. So I hope those videos were big enough and you enjoyed the demos of some of those features. But we have a lot coming down the line, and I'd like to talk about a few of these. They're kind of in order of what's nearest to farthest. But first, we're working on providing enhanced NFT metadata, specifically for collections, and we also want to provide data around sales and listings. Next, we want to give users the ability to export a full transaction history for a date range, so this can be pretty useful for things such as computing your taxes. Next, we want to provide event streaming so that users can listen to and subscribe to events that they care about and react to those in real time. And then further down the line, we'd like to provide indexing support for more different kinds of VMs besides the EVM. The first one we'd like to target is VMs built with the HyperSDK, which if some of you were there, Patrick talked about yesterday. And lastly, we would love to provide Glacier as a service. So packaging all the power of this essentially into a box where you could run it for any chain you wanted and build out a private API, a private version of Glacier for your chain, rather than needing it to be integrated with our centralized solution. So, as I mentioned, Glacier is available today in beta. I have some resources here. This is where you can find our open API spec, and it also has links to other resources where you can file bugs, file feature requests, and also just file security issues as well. And if you have any questions, please reach out on the Discord as well. I try to be active in there when it comes to any questions about Glacier. And I'll also be at the summit the rest of this week, so if you find me and have any questions, feel free to grab me and talk to me about Glacier. So with that, I want to thank everyone for coming, and does anyone have any questions? Yes. We're working on a variety of ways to provide event streaming.
Yeah.
Do you want to say it again so everyone can
Yeah, so just asking if you guys are just watching the emitted events from the contracts in order to ingest that data and then serve it up through Glacier.
Yeah, exactly.
Yeah, right.
So we're looking, I assume you're talking about for the ERC tokens?
For the tokens and the, yeah, exactly. And
for the ERC
NFTs,
tokens,
we
looked at the log data to see when the transfers happen according to the spec and index it according to those. We would love to get to a place where we can kind of make that a little more configurable and listen to arbitrary events if someone's interested in some new kind of ERC token. that
Sure.
has a different kind of transfer mechanism.
Yeah.
We'd love to be able to add an easy way to listen to that and serve that in the API.
Yeah, and in the logs, is it uniform, or are there different ways that can be expressed? So it's like pretty complex for you.
The blockchain is a little so-so on
Right.
standards.
Sure.
Generally for ERC20s and 721s and 1155s, they are pretty conformant to the standards, at least when it comes to transfers. So
Yeah.
that's been a good way for us to track those kind of interactions.
Cool. I'm an avid user, so thanks, man. It's cool.
Sorry. You want to wait 1 second?
Hi. So in case NFTs are implemented, like a 7-to-1 NFT is implemented in the way that metadata is not on IPFS but on chain, does the API support the way to, let's say, to index not just the transactions and ID of that NFT, but also the data behind it?
Yeah, so if you're saying if the metadata is on chain rather than stored somewhere else. So yeah, our metadata indexing handles a variety of, I guess, storage solutions that users might use for NFTs. As I just mentioned, there aren't great standards, but we try to index as much as we can and add new use cases as we see important ones arise. But one of the use cases we do support is if the data is stored directly on chain, we do index that and try to parse that out so users don't have to do that themselves.
All right. May I ask what kind of database do you use to hold and query all of that data?
We use a couple different ones. It depends on the use case. I don't know if I want to disclose exactly the technical stack.
Thank you.
But we use a variety of relational and non-relational databases to index this. Our goal is just to be able to serve data as fast as we can so that users aren't, when building your front-end application, you're not beholden to how fast you can get the data.
All right. Thank you.
As someone that loves to use a lot of different blockchain APIs, I find it really useful when all the documentation is stored in a way that I can programmatically grab all of the types, be able to query endpoints with great examples, and maybe even generate a service automatically based off of some sort of documentation spec. So is that something that Glacier can support?
Yeah, so Glacier does have an open API spec. The slide before here, this link right here, does have a link to our open API spec, so you can try it out directly there using the Swagger UI. You can download the open API JSON yourself, and from that, there's a variety of code gen tools to build clients in your own language, whichever one you want. And we do our best to keep the documentation up to date. It'll definitely get better over time, but again, please, if you see that lacking or would like better examples, please let us know. We're happy to add those.
Will every new EVM-based subnet automatically be indexed, even on Fuji? And if not, to whom I have to talk if I want to get my own EVM subnet included in the index?
Great question. So we don't index every chain automatically, but we are fully EVM compatible, so it's very easy for us to add one. But we do manage our relationships with subnet operators in order for us to come to an agreement on the indexing costs. But the Ava Studios team is a great team to reach out to. I don't know if we have Anand, do you know if we have a direct channel to them? What would that be?
Go through Discord.
Discord? I think Discord might be the best bet. Our developer relations team there probably can route you to the best people to talk to in order to figure out how to get the chain index. But we do, when we're managing a relationship with a subnet coming online, one of the questions we always ask is, do you want this kind of data index for you? And so most of the subnets coming online where we have a relationship, they are asked this in the onboarding process.
All right, thanks.
Yeah, and with our new Ava Cloud offering, some of that's going to be automated away, so you can say, hey, I want this to be indexed as part of Glacier, and so it'll automatically be added when we spin up the subnet.
quick questions about ERC 721. I looked at the API yesterday and didn't see any function to trigger metadata refresh. So is there a way to do that when you know something changed but you want to get it updated?
No, that's a great question. We actually have the endpoint. We're still testing out some kinks. It should be released along with some of the improved NFT data indexing, like collection indexing. So it's coming soon. We have the endpoint available, just not quite out in production yet.
And what about floor prices on popular exchanges?
Floor prices, so when we're doing our indexing of sales data and listing data, we're also going to be trying to return floor prices as well. So that will be included also.
Okay, thanks.
Hi, so just a general question. Let's say we have some custom smart contracts and some custom events, and let's say I want to check number of NFTs sent or received from this specific address, those specific NFTs. How would we index that data and get that data, for example?
So if it's one of the existing ERC specs we index, there should be an endpoint for you to kind of track that if you know the address. If it's a new custom ERC compliant token, that's not one of the ones we index today, or it's just some custom smart contract.
Yeah.
We don't currently have a way to give users the capability to say, hey, I'm interested in this. Can you please index this and denormalize it so I can
Yeah, so you
query
need
it
some
quickly?
Compliant API files and everything to be able to...
We would love to get to a place where we can let users be more in control of the indexing, but not available yet.
Yeah, thank you.
Hi. Some of the APIs already deprecated in the public API, in the P chain. Do you think it will be moved to the Glacier API, or you will be replaced in the public API or our own node APIs in Avalanche, I mean?
Yeah, we're talking about that internally. We are aware of the platform API deprecations, and so we do think Glacier is a place where a lot of those APIs can end up living because we can index that data separately and serve it from Glacier. So it's likely that some of those end up in Glacier in the future, in the short term.
Yeah, hello. I have a question regarding like how it will be evolving. Is the idea to let's say for pricing wise, that you can start paying for it and get higher rate limits, or is the end goal more that you start running it yourself if you need higher throughputs? Or
right now, our plan is to have it be a hosted solution. So we are working on a plan for general availability, and that will include the ability to create API keys where you pay for higher rate limits depending on your needs.
okay, thank you.
I guess one more point on that front is even when, as I mentioned, all of our front ends use it today, and they use the same rate limits that we have on the free tier right now. So you can probably get by mostly with the rate limits that exist today, but I'm sure there are scenarios where you might need the higher rate limits depending on your use case. All right, one more.
How does Glacier ensure stability to make sure that it has great uptime and is serving real-time data? And are there any sort of mechanisms in place to let us know when the data might be falling behind, if that case ever does happen?
Yeah, so a little bit behind the scenes of the tech stack. Each chain that we run indexing for and serve data from for Glacier is backed by a redundant set of nodes, and we run it in multi-regions as well to try to provide the best performance. But there are a lot of cases where the nodes can go down, or the chain itself can go down. For instance, if the validation state falls below a certain threshold, it essentially stops serving data. So Glacier on the chain's endpoint also provides some information about whether that chain looks available or unavailable, so that you can relay that information to your users. So if the chain itself is having problems, rather than showing stale data without any indication of what's going on, you can say, hey, this chain seems to be having problems. And as soon as it comes back online, it has a status indicator stating that. All right, I think that's it for time, but thanks everyone for coming, and thank you for the questions.